All right, Algebra 2, we're going to go over solving absolute value inequalities. And we're going to do these simple ones where the absolute value is already isolated. In today's class, gave you the notes, how to solve them. First step was to isolate the absolute value. That's already going to be done with these problems here. Second step is going to be to set up a compound inequality. We got two types, more is or, less is nest. And then after we set them up, third step is to solve the compound inequality. And the fourth step is to check your answer. So number one, absolute value of 2n plus 10 is greater than 6. And as I said, more is or. This is a more statement. More is or. That means that we are going to set up an or statement. 2n plus 10, drop the bars, greater than 6, or 2n plus 10, flip the sign, make it less than, and take the opposite, negative 6. So we got our two equations. We're going to solve each of these. So subtract 10. We got 2n is greater than negative 4. Divide by 2. N is greater than negative 2. And do the same thing over here. We'll get a different answer. 2n is less than negative 16. Divide by 2. N is less than negative 8. So we have n is greater than negative 2 or n is less than negative 8. We can graph it. We go up. Put an open circle at negative 8, put an open circle at negative 2, and we want less than negative 8, so that's to the left. We want more than negative 2, that's to the right. We can write it as an interval, so keep in mind that negative infinity is over there to the left and positive infinity is there to the right. And this first part is going from negative infinity all the way to negative 8. And we would have parentheses there, union. And the second one picks up at negative 2 and goes all the way to the right, to infinity. So that's the first one. Second one, absolute value is less. Less is nest. Less is nest. Or is or. So on this one, well, we're going to drop the absolute value bars again. We have negative 2 plus 3a is less than 7. And nested between negative 7. So just take that inside the absolute value, stick it between the number and its opposite on this side, making sure that the symbols are less than. And now we want to get the a by itself in the middle. So whatever we do to the middle, you do to the left, you do to the right. We get negative 5 is less than 3a, which is less than 9. Divide everything by 3. We get negative 5/3 is less than a, which is less than 3. To graph it, we go up, find negative 5/3, which is negative 1 2/3, so that's right about there. Open circle, and find 3, open circle, it's not equal. And this is nested between the two, so we shade between. To write the interval, since it is an open circle, we use parentheses, and it starts at negative 5/3, and it goes to 3, again with parentheses. Parentheses are when we have an open circle, and it's less. It's not equal to, I should say. All right, so number 3, absolute value of 6 minus 5p is less than or equal to 21. So again, here we have a less is nest, except now it's going to be less than or equal to. So 6 minus 5p, less than or equal to 21, nested between negative 21, 21, should look like that. Subtract 6 from both sides, from all three sides, I should say. And we get negative 27 is less than or equal to negative 5p, which is less than or equal to 15. At this point, we divide by negative 5. Since we divide by a negative, it's going to flip the inequality sign, so now they're going to be greater than or equal to. And we have 27/5 greater than or equal to p, which is greater than or equal to 3. Negative 3. We can flip this around and put the negative 3 is less than or equal to p, which is less than or equal to 27/5. And we can graph that above. So negative 3, put a closed circle. 27/5 is 5 2/5, so that's about right there. And it's between it, so we shade between. As an interval, we would use a bracket because it's equal and it's a closed circle. And we'd start at negative 3 all the way to 27/5 with a bracket. Number 4, absolute value is greater than or equal to More is or, so this is another or statement just like number 1. And so we're going to write negative 8x minus 6 is greater than or equal to 46, just the same thing. Or start out the same, flip the sign, and take the opposite, which is negative 46. And now we're going to add 6 to this one, and we get negative 8x is greater than or equal to 52. Divide by negative 8. Dividing by negative, we need to flip the sign. And negative 52 over 8 reduces to negative 13 halves. And we go over here, we add 6. We get negative 8x is less than or equal to negative 40. Divide by negative 8. We get x is greater than or equal to 5. And this is an or statement. And we go up above. Negative 13 halves would be negative 6.5. So it's going to be right there. It's going to be a closed circle. And we would shade to the left because it's less. And 5 would be right there. And we would shade to the right. And again, we could write this as an interval, negative infinity to negative 13 halves with a bracket because it's equal, because it's a closed circle. Union, bracket, picking up at 5, going all the way to the right. The last two that I have here represent special cases. So the first one, we have absolute value is less than a negative. And normally when I see absolute value is less than a negative, right away I think absolute value is distance. When can distance be less than a negative? It can't happen. It's going to have no solution. But if you did try to solve it using the above methods, you would nest it between negative 11 and 11. So the positive 11 would be on this side, except when you solve it and you add 11 to everything, you would get a contradiction. Add 9 to both sides, add 9 over there. We get 20 is less than m, which is less than negative 2. And that doesn't make sense. How can 20 be less than a number which is less than negative 2? So this is, again, no solution. But in general, you don't need to write that. You can just write no solution. You can also use a circle with a line going through it, or some empty braces to write no solution. Number 6, this one has absolute value of n minus 9 is greater than or equal to negative 6. So when is absolute value bigger or greater than or equal to a negative? Well, absolute value is distance. Distance is always non-negative. It's always at least 0. So this always happens. This should have all reals as the solution. And again, if you didn't realize that right away and you did work it out, you would have an or statement. You have n minus 9 is greater than or equal to negative 6, or n minus 9 is less than or equal to positive 6. And when you solve this, you have n is greater than 3, or n is less than or equal to 15. What numbers are greater than or equal to 3? Well, that would start here. Or less than 15, I would start over at 15 and go this way. Every number is going to be hit. Because it's an or statement, either one could be satisfied, and every number satisfies at least one of these. So it is all reals again. Again, recommend not. You don't have to show your work for me. Just realize that absolute value is always bigger than negative, and you always get all reals, which you can write like that. You could abbreviate with the letter R, or you can write as negative infinity to infinity with parentheses around it. The infinities always have parentheses when we write as intervals. So, hope that helps, and let me know what you think. We'll see you. Bye.